Hello dear student, welcome on this video lecture. And in this video lecture we will be moving ahead on vector algebra that we are studying. In the previous video you have learned about one type of product of two vectors that was known as dot product or scalar product. Now we will be covering cross product, which is also known as a vector product. So let's say we have been given two vectors. Let's say this picture shows this a vector A and this is a vector B. These two vectors are known to us, and this is angle between these two vectors, so theta is also known to us. So if these two vectors and theta is known to us, so A will be magnitude of vector A, B will be indicating magnitude of vector B. So cross product of vector A and B are defined as follows. So the definition of this cross product is this. We will be writing as A vector, in between there will be cross, then B vector. So if we find this kind of expression in which A vector and B vector and in between a cross is written, then we will read it as A vector cross B vector. And its definition is, we will be need to write the magnitude of first vector, so the magnitude of A vector, then magnitude of second vector, which is magnitude of B vector, into sine angle between the two vector, which is theta over here. So this becomes the magnitude, and with this we need to place a unit vector. So let's say this unit vector I am indicated by n cap, or you can call it as eta cap. Now to make it simpler, we will call it as n cap. Sometimes we can also use eta cap. So this n cap is the direction, and this entire stuff is a magnitude. So we can rewrite it in a simpler looking form. So this can be written as A vector cross B vector is equal to magnitude of first vector, magnitude of second vector, into sine theta, which is angle between the two, and n cap. So this is how cross product between two vectors is defined. Right, now here you will find on the right hand side there is a direction involved. Since this is a direction involved, so right hand side is a vector, and A is a vector, B is a vector. So when we do the cross product between two vectors, result is also a vector. Hence we will be claiming A cross B is going to be a vector quantity, unlike A dot B, which used to be, or which is, a scalar quantity. Hence this is also known as vector product. Now since this A cross B is a vector quantity, so it must carry its direction and magnitude. So we need to know what the magnitude and direction these values or these things are. So we can claim from here, first point that we can claim is this A cross B is a vector. So A cross B is a vector. Now whenever we get a vector, we need to talk about the magnitude. So what the magnitude of this vector is going to be? So magnitude of A cross B will be written as mod of A vector cross B vector. So when we place this mod, that indicates magnitude. Now we are trying to find the magnitude of cross product. Now so we can place this magnitude mod symbol on the right hand side as well. So it's going to be A, which is a positive number, B, which is a positive number, sine theta, and n cap. Now there's a properties of mod operation. So when we apply this mod on the numbers or quantities which are in multiplications, we know this can be applied separately on all the quantities, or we can say positive multiple quantities can be taken outside. So A is going to be positive because it's a magnitude of vector A. B is going to be positive because it's a magnitude of vector B. Moreover, you will find sine theta is going to be positive because this theta runs from 0 to 180. So angle between the two vectors will be running from 0 to 180. So it's going to be run from 0 to 180 or pi degree. So up to between these limits, sine theta, for this limit we know sine theta remains positive. So you might be knowing by from the trigonometry that this number is positive, greater than or equal to 0. So since it's a positive, so these all numbers are positive, so they can be taken outside. So it becomes a b sine theta. Since they are positive, so there is no need to place this modulus value. And this is going to be mod of n cap. We know this is n cap is a unit vector, and the magnitude of any unit vector is 1. So since magnitude of any unit vector is 1, so we can place it as a unity. So from here we got one important expression, that the magnitude of cross product of two vectors is given by a b sine theta. So if the theta is known to us and the magnitude of individual vectors are known to us, then we can claim the magnitude of cross product of those two vectors is going to be a into b into sine theta. And since this magnitude is always positive, so ab sine theta will be always positive for all values of theta which runs from 0 to pi or 180 degree. Now once we have talked about the magnitude of this cross product, next important point is to understand what the direction of this cross product is going to be. And this point, that is direction of cross product, is perhaps the most important aspect and most challenging aspect in this vector algebra. And if you have understood this properly, then you will find in many chapters of the physics your calculation, your solving of the problem will become very easy. So magnitude is this we have talked about. Let's talk about the direction. So what the direction of this cross product A cross B is going to be. So if you look at carefully, then it is basically indicating as this is the magnitude and this is the direction. And you remember very beginning of this vector topic, we talked about that any vector can be written as a magnitude and direction. That means this n cap is basically the direction of A cross B. So we can say the direction is represented by n cap. So direction of A vector cross B vector, that means this is a new vector, its direction is given by n cap. So this n cap is indicating the direction of A cross B, or in another term we can say n cap is basically the direction of A cross B, that means A vector cross B vector's cap. Now point is to understand what the direction of this n cap is. So let me give few points regarding that. So we will be having 2 points to decide the direction of n cap. So one point, let me indicate over here in short. This one point that we are going to use is this: the direction of n cap is going to be, this direction of n cap is going to be perpendicular to vector A. So the first vector, A means the vector first. So this n cap is going to be perpendicular to vector A, as well as it's going to be perpendicular to vector B. So that means the direction of cross product is perpendicular to both the vectors involved in the cross product. Very important point. So n cap is perpendicular to A direction, n cap is also perpendicular to B direction. It's a symbol and, that means both are simultaneously true. In case you combine them together, then we can claim something like this, that n cap is basically perpendicular to the plane of vector A and vector B. Let me explain this first part completely and then we will go for the second part. So let's say this is vector A in the picture, this is vector B, and we are doing this cross product A cross B, and somebody wants to know what is the direction of A cross B is going to be. So we need to make sure that this first point is applicable and this first point is applied properly. Now we need to find such a direction which is perpendicular to A vector. Now this is A vector, and if somebody asks how many directions are existing perpendicular to vector A, then you will find this is the direction which is perpendicular to A, You can also say this is the direction which is perpendicular to vector A. That means they are at 90 degree. But these are not the only directions which are perpendicular to vector A. In fact, you are going to get infinitely many directions which are perpendicular to vector A. For instance, if you consider any direction which is perpendicular to this white board, that is also going to be perpendicular to vector A. Moreover, if you look from the side, then you can draw several perpendicular directions. For instance, if somebody watches from here and looks the vector A from this side, this view, then the vector will be looking like this. And all these directions are going to be perpendicular directions. Now this is something to visualize. Now this dot that I have shown, this is basically talking about the vector A. That means if you are somebody looking from here, then the vector A will be looking like it's coming outward to this white board. So if it is coming outwards, so all these directions are perpendicular to that direction. Is it making sense? So point is, the number of directions perpendicular to any line are infinite. Out of those infinite directions, we are looking for a specific direction which is denoting A cross B. So that direction has to be perpendicular to A and perpendicular to B. That means in nutshell we can say it's perpendicular to the plane in which the vector A and B lie. If we look this as an example, then you can see the vector A lies on the plane of this screen and the vector B is also lies on the plane of this screen. That means vector N must be lying perpendicular to the plane of this screen, and anything that is perpendicular to the plane of screen is going to be perpendicular to A as well as perpendicular to B. So that means this N cap is going to be perpendicular to this screen or whiteboard that you are able to see. Now when we talk about the perpendicular to this screen or whiteboard, there are going to be two possible directions. One direction is going to be perpendicular to the screen, which is coming towards you, that means pointing outwards, and another direction will be pointing inwards and perpendicular to the screen. So we will be making symbol. If we do not like this, we make a point and we encircle it. So this will be indicating the direction which is perpendicular to the plane or white plane on which this has been drawn, and this will be outwards. So outwards direction will be indicated or will be indicated by a point and encircle. And if we make a cross and then encircle this cross, then this will be indicating perpendicular to the plane in which it has been drawn, but it will be into the plane or inwards. So these are the symbols that we use to identify the another third direction which is perpendicular to the plane. So whenever you get this kind of symbol, think about that this is direction which is perpendicular to the plane and it is coming outwards towards the viewer, and this symbol is talking about the direction which is perpendicular to the plane and going inside. Making sense? So that means this A cross B direction or N cap direction in this particular case will be either given by this outward direction or it will be given by inward direction. So this first point will let us know two options available for the direction. Now initially there were infinite number of options which were perpendicular to direction A, infinite number of options were perpendicular to the direction B. Out of those infinite options, combining the two together, we are able to reduce the options in two. That means either it's going to be outward or it's going to be inwards and perpendicular to the plane of board, because A vector and B vector both has been drawn in the plane of board. Now to decide the final answer, that means to choose the correct out of these two options, we should be using the second point. The first point is quite important, and after this first point we can use the second point. Now second point is right hand rule. So we will going to use right hand rule, or we can call as a right hand thumb rule. So I'm writing in simple manner, right hand rule, right hand rule. Now this right hand rule will be able to make us correct choice, or this will make us able to correct choice out of the two options that are going to be available. So once we applied the first point, then we will be reducing two options to choose from, and the second point will be deciding out of the two which one is the correct. Making sense? How to use this? Again, we can't see each other, so I can't explain the movement of hand, but you need to imagine that. Now you look your right hand and make it free and stretch your palm so that fingers are collected together. Thumbs is free, so make thumb free and collect all the fingers and stretch the palm. Now when you stretch your palm and fingers are pointed collectively in a particular direction, then naturally you can curl your finger in a particular sense. So when you want to curl your fingers, you will be curling your fingers towards your palm. You cannot curl your fingers opposite to your palm. That means backward direction fingers cannot be curled. So we say natural curling of fingers, that means fingers has to be curled toward the direction or towards the palm. Okay, so what we need to do, we need to keep the palm of right hand stretched, and once we have kept this right hand palm stretched, then the fingers direction is going to be considered as a direction of first vector. So here we are doing the cross product of vector A and vector B. So for us the vector A is the first vector, so this vector A is the first vector and the B is the second vector. So in the first vector direction we will be pointing our fingers, so we will be orienting our stretched palm of right hand in such a way that the fingers are aligned in the direction of first vector, which is in this case this vector, first vector. Right, so try to align your right hand's stretched palm's finger in the direction of first vector. Once you do this, then you can rotate your hand in any way, keeping the direction of fingers in the direction of vector A. Then after, or take the orientation in such a way so that you can curl naturally towards B vector. So you need to place your fingers pointing in this direction, and so that this part is your palm and these fingers can be naturally curved towards B direction, that means like this. So if you curl your fingers in the direction of B, then you can find where your thumb is going. So the thumb, you can see whether this thumb is coming outward to the plane of this board or going inward to the plane of this board. If it is coming outward to the plane of board, so that will be outward direction. If the thumb is going inwards, so inwards will be the direction. So point is, we will be placing our stretched palm right hand fingers in the direction of first vector, and we will be curling naturally those fingers in the direction of another vector. In doing this, wherever thumbs goes, that direction becomes the direction of cross product. Since we had two options left, then simply orientation of thumb will let us know which direction is right direction. So if you have done this thing, that means you have placed the fingers along the vector A and have curled naturally towards the vector B, then you can observe your thumb is pointing outwards, or that means outwards to this screen. That means A cross B will be in the outward direction. So since here, as per your experiment or this right hand rule, you found from vector A to vector B, if we are curling our right hand fingers, then thumb is pointing outwards, hence the direction is outwards. So from here we can claim that the direction of n cap is perpendicular to the board and outwards, which we can show by this symbol, and we know this is outwards. Is this making sense? If it is making sense, then cross product is almost over as far as the concept is concerned. So this direction is quite important. Let me quickly summarize what the definition was and how we are using this. Direction and then we will be having a couple of example to digest this thing properly, and we will talk about some properties as well. So A cross B is a cross product which is a vector product. It is defined as AB sin theta and n cap, and AB sin theta is the magnitude. AB sin theta is the magnitude of this cross product because this cross product is a vector quantity, and direction of this A cross B is given by n cap. To determine the direction, we use these 2 points. The first point, that this vector or this A cross B vector or n cap direction is perpendicular to both the vectors individually. That means it's perpendicular to the plane in which the two vectors lies. So we will first identify the plane, and we will be having two directions perpendicular to the plane, one outside the plane, another inside the plane. Out of the two directions, right direction can be identified using right hand rule, in which we will be stretching our right hand palm and placing the fingers in the direction of first vector and curling them in the direction of another vector naturally. Then thumb if it is outward, so outward direction; if it is inward, so inward direction. Making sense? Now based on this, let's take an example and try to find the magnitude and the direction of cross product. So let's say there is an example, and we will be using this example to understand how to get the magnitude and direction. So it says there are two vectors, vector A, vector B, and theta is the angle. We have been given A as a 2 magnitude, B as a 4 magnitude, theta as a 30 degree, and we need to answer these 4 parts of this question. First part is saying mod of A cross B. So this mod of A cross B is the magnitude of vector A and B's cross product. So as per the definition of this A cross B's magnitude, we can write it as this is going to be equal to this A cross B is going to be equal to A into B into sin theta. Now we have been given all the values, so we can put the value. A is a 2, B is a 4, and it's going to be sin theta. Theta is 30 degree. So we will find it's going to be 8 into sin 30, which is going to be 1 by 2. So ultimate answer will become 4. So whatever the unit will be, we can place the unit over here. So A cross B's magnitude is going to be 4. It's a positive number. It was supposed to get a positive number. Making sense? Now next point is direction of A cross B. So we need to find the direction of A cross B vector. So we say that direction of A cross B will be perpendicular to vector A, perpendicular to vector B. That means perpendicular to the plane in which the vector A and B have been shown. So A and B have been shown in the plane of this board, whiteboard. So it's going to be perpendicular to this whiteboard. Then we need to find whether it's outward or inward. So we will be using the second rule, which is placing our right hand palm stretch fingers in the direction of first vector, which is vector A. And we will be curling our fingers from this direction to this direction. So natural curling this direction will lead us to find this thumb is in the outward direction. So we will say this direction is going to be outwards or outward to the plane. So we will say perpendicular and outwards to the plane. Perpendicular and outwards, which can be shown by this symbol dot and encircle. Outwards to the plane means perpendicular as well as outwards. Making sense? And next part is magnitude of B cross A. That means we are changing the order. So if we are changing the order, we will be using the same formula. Magnitude of first vector, magnitude of second vector into sine of the angle between the two vectors. So whether you see theta as the angle between A and B or B and B, both are the same thing. So B value is 4, A value is 2, and sin theta is going to be 30 degree or sin 30 degree. So it's going to be half, then we can find it out, it's going to be 4. Now from here, one thing we can conclude, that's the magnitude of A cross B and magnitude of B cross A is going to be identical, because AB sin theta is equal to BA sin theta. So that will become one of the property of cross product. Now let's talk about the direction and see whether the direction of A cross B is same as the direction of B cross A. So if B cross A is being asked for direction, then we will say the direction of B cross A is going to be perpendicular to B and perpendicular to A. That means it will be perpendicular to the plane. That means it will be again perpendicular to the plane of whiteboard that you are able to see, or the screen that you are able to see. Now perpendicular to this screen, again there are two directions, one is outward, another is inwards. Now then, to decide which one is the right, for that sake we will be using right hand rule. As per the right hand rule, we will placing our stretched palm finger in the direction of first vector. Here the first vector is a B vector. So we will placing our right hand palm's stretched finger in the direction of first vector. So we will be placing our finger in this direction in such a way so that we can have a natural curling towards another vector, which is A vector, so that we can have a curling like this. So try to place your right hand fingers of stretched palm in the direction of B vector and place in such a way so that you can curl naturally your fingers in the direction of A vector as shown by the arrow. Then you will be able to see the thumb is, in this case, is not outwards, rather it is pointing inwards. Can you see that? If you are able to see that, that means you are able to identify the direction. In this case, the thumb is going inwards. So the direction is going to be perpendicular to the plane and inwards. So that's going to be inwards. And as per the symbol, we are going to denote it as by cross and encircle. Now from here we must be able to identify another property, that the direction of A cross B is not same as the direction of B cross A. Rather the direction of A cross B and B cross A are opposite. If one cross product is outward, then reversing the positions, the direction becomes opposite. However, their magnitudes are identical. This is what we can conclude out of it. And if you have understood how we are able to write this direction, then our purpose of finding out direction is over. So from here, what the conclusions we can make, there are some conclusions that we can make. These two conclusions are: magnitude of A cross B will always be equal to magnitude of B cross A. So this is one of the conclusions that we can draw for any two vectors A and B. Another thing that we can conclude is A cross B direction is not equal to B cross A direction. Since directions are not equal, so that means these two vectors cannot be equal. So we can say A cross B is not equal to B cross A. That means A and B, the cross product of A and B is not commutative in nature. That means we cannot change the positions. If we change the position, vector changes. It is different from the dot product you can think of. One more thing we can have understood, or we can think from, that the directions are exactly opposite, and we have talked about whenever the directions are opposite, we multiply with a minus sign to reverse the direction. So we can say this A cross B basically is going to be equal to minus B cross A, minus B cross A. Because the equality was not because of the direction, so we reverse the direction of B cross A, so it will become in the direction of A cross B. Is it making sense? So that's important property you need to remember. That means A cross B is always equal to minus B cross A. If we exchange these terms or vectors, then you will find the direction is going to be reversed because of this minus sign, and then they will become equal, right? So these are kind of properties of cross product that you can note down and remember. Magnitudes are identical, directions are opposite, hence the vectors are opposite vectors. So we can say A cross B vector and B cross A vector are opposite vector, or we can say negative vector. Okay, and let's move ahead and talk about few more properties of this cross product. So let's talk about the properties of cross product. There are several properties. So first of all, the definition of A cross B is AB sin theta n cap. We have understood this AB sin theta is a positive quantity and it is the magnitude of A cross B. This n cap is the direction of A cross B. This direction is perpendicular to vector A as well as vector B, that is perpendicular to the plane of vector A and B. Moreover, it follows the right hand rule. As per this right hand rule, we are able to decide the appropriate direction of A cross B. Now, in terms of properties, we can say one of the property is that means this A cross B is a vector quantity, and this is having a direction which is determined by right hand rule, and it's perpendicular to vector A and vector B. So that's also a property. So let me write in short, this n cap is perpendicular to vector A, and this n cap is also perpendicular to vector B, and this n cap is indicating the direction of A cross B. We have just talked about that this cross product is not commutative, that means A cross B is not equal to B cross A, not equal to B cross A. So if we exchange their positions, direction is opposite, and we can say if we want to apply the equality, so we need to place a minus sign. So this is equal to minus B cross A. So that's an important point that we have talked about. As far as this distributive law is concerned, like if it is written as A cross B plus C, so this cross product is distributive over addition. That means we can take this A inside, but keeping in mind the order should not change. So keeping the order intact, we can go ahead and we can write A cross B plus A cross C vector. This is allowed, but this order has to be maintained. So distribution is allowed, however the commutative law is not valid. Moreover, we can further say, let's say we are trying to find the maximum value of this modulus. So mod of A, we know this mod of A cross B is equal to AB sin theta, right? So if we are interested in finding the maximum value of this cross products mod, so we know this maximum value will be occurring for that value of theta for which sin theta becomes maximum, and sin theta's maximum value is 1, so it will be equal to A into B. That's the maximum value of cross products magnitude, and it will be occurring when sin theta is equal to 1, that is theta is equal to 90 degree. That means whenever the two vectors are perpendicular to each other, their cross product has a maximum value, and it has simply magnitude of A into magnitude of B. Making sense? Now its minimum value will be 0. So we will say this minimum value is going to be 0 if sin theta becomes 0, and sin theta is 0 for 0 or 180 degree. So if theta is 0 degree or theta is 180 degree, that means the two vectors are parallel or anti-parallel, or we can say collinear. So if the two vectors are collinear, then we will find their magnitude of cross product will be 0. That means in fact the cross product will be 0. So A cross B will become null vector. So whenever the angle between the two vectors is 0 or 180 degree, that means the two vectors are collinear, their cross product is 0. So that becomes an important condition for getting collinearity. So if two vectors has to be identified whether they are collinear or not, we will do cross product and check whether it's coming to 0 or not. So this is condition for checking collinearity of vectors. So we can say for collinear vectors, cross product is 0. It is just like dot product is 0 for perpendicular vectors, and cross product is 0 for collinear vectors. Okay, so this is plural, so we can write its vectors. We can go further. We can talk about few more properties. Like let's say we are having a vector A, and we want to make the cross of the vector with itself, same vector. So we know the angle between the same vector is 0. They are always collinear. So using the above property, we can say it's always going to be null. So whenever we do the cross of one vector with itself, it's always going to be equal to 0 vector or null vector. Using this property, we can talk about how this I cap, j cap, k cap behaves. So if we go for I cap cross with I cap, so we can say we are doing the cross product of two collinear vectors is going to be null vector. Similarly, if we say j cap cross j cap, so it's going to be 0 vector, and if we are getting k cap cross k cap, then again we will get a null vector. Mind it, when we used to do the dot I, it used to be unity, whereas I cross I becoming null vector, z cross z becoming null vector, k cross k becoming null vector. Okay, making sense? So this is how we can find this cross between identical vectors. So there's identical vectors or parallel vectors or collinear vectors. You'll find their cross product will be 0, and it will be maximum for 90° and other properties that you have seen. Let's talk about what happens when we multiply two perpendicular unit vectors like I cap and j cap in cross fashion. So let's say next point we are considering in properties of cross product, which is continued over this slide, and we are focusing on finding I cross j. So we know I and j, they are perpendicular to each other, so their angle is going to be 90°. Magnitude of first is going to be 1, magnitude of second is going to be 1, into sine, angle between the two is 90°, and n cap. So we will find it is turning to be n cap. Now this is going to give us an important conclusion that cross product of two unit vector is a unit vector. That means it's trying to say the cross product of two directions is another direction. Making sense? And now let's try to identify which direction this indicates. To identify this direction of n cap, let's use this right hand coordinate system, and this is indicating x-axis, or this is our x-axis. Let's say this is y-axis, then this is z-axis. We know that direction unit vector in this direction is going to be I cap. The unit vector in this direction is going to be j cap. The unit vector in this direction is going to be k cap. So this I cap, j cap, k cap, they indicates the directions along the x direction, y direction, z direction. Now here we are to multiply in cross fashion the direction of x with the direction of y. So I cap cross j cap. Now we know this, if I cap we do I cap cross j cap, then we can find the direction of the cross product, because we have learned the direction of cross product, how to identify. Now this picture is a three-dimensional picture in which x and y, they are lying in the plane of this whiteboard, and this z is coming outwards. So though it has been shown in this board, but it is pointing in the outward direction. This is three-dimensional. I hope that's making sense to you. Now if we are finding the direction of I cap cross j cap, so how to find the direction? To find the direction of this, we can say we need first of all this vector which is coming equal to n cap. So that means this n cap has to be perpendicular to I cap, perpendicular to j cap, that means perpendicular to this whiteboard. That means either it will be outward direction, that means either it will be in z direction, or it will be inward direction, that it will be in minus z direction. That means this n cap will have a two option, either it will be k cap or it will be minus k cap. Making sense? To decide whether this n cap is out of the two options, let me write this n cap will have a two option now, either it will be in the direction of k cap, or this will be in the direction of minus k cap. Now to identify which one is the correct, for that sake we will be using the right hand rule. As per the right hand rule, we will be placing a stretched finger of right hand in the direction of I vector, and we will be orienting in such a manner so that we can have a natural curling towards j vector. So if we do place our right hand's stretched fingers in the direction of this and try to curl in the direction of y, then you can see the thumb is outwards. Since thumb is in the outward direction, then it's going to be along the z direction, which is k cap, and not the minus k cap. Have you got this? Or let me explain again. So we have placed, or you need to place your finger in the direction of I cap. Just do that. Place your right hand fingers in the direction of I cap. In such a way you can naturally curl your finger in the direction of y, so your fingers has to be curling like this. So if you curl your finger in this direction in this particular mode of orientation, then you find z, this thumb will be in the outward direction. So thumb gives us the direction of cross product. So from here we have decided this is going to be the direction, that means outward, not this. Once we have decided this, that means n cap came out to be k cap. So we got a relation or formula that I cap cross j cap, this is going to be equal to k cap. An important expression. So whenever we are going to go do this cross product, this is going to be play important role whenever or wherever we will find I cap cross j cap, we will be replacing this I cap cross j cap with this another direction which is k cap. So cross product of two directions is a new direction which is perpendicular to both and follows the right hand rule. Making sense? If it is making sense, then we can find out other cross products of these unit vectors. Like next one, if I am interested in finding out next, let's say, which is j cap cross k cap. So can you find out what this direction is going to be, j cap cross k cap? It has to be perpendicular to j, perpendicular to k, that means it must be in the direction of I cap or minus I cap. Then you use the right hand rule. If you use the right hand rule, place your fingers in the direction of j vector of right hand, try to curl in this way so that they are pointing toward, or curling, natural curling occurs in the direction of k cap. That means outward curling if you do by placing your fingers in the vertically upward direction, then thumb will be moving in the rightward direction. You can see by doing this experiment, or if you do this, find this, then you will find this is going to be equal to I cap. So j cap cross k cap converts into I cap. Similarly, if somebody asks for k cap cross I cap, so again this has to be perpendicular to the k cap as well as I cap, that means it must be in the j cap direction or minus j cap direction. Again, placing your finger first in the direction of z, that means outward, you place your fingers in the outward direction and orient in such a way so that you can curl naturally these fingers in the direction of x. So you will see the thumb will be moving upward direction, so thumb will be pointing in the upward direction. So if we place our fingers outward the screen and curl towards x direction or I cap direction, thumb will be in the upward direction, and then you will realize this upward direction is a j cap, so that becomes j cap. So these are important expressions for cross product of these unit vectors, and I'm hopeful that you are able to digest how we are getting these directions. If you are getting any issue, repeat this video and try to learn the direction aspect and try to practice by placing your fingers of right hand curling naturally and looking at the thumb. Now just like we have got this, now we can also find out the other parts of it. Let's say somebody asks for finding this j cross I. So if we are looking for j cross I, again it's going to be unit vector perpendicular to j, perpendicular to I, that means it will be in the direction of z, that is k cap or minus k cap. Now you can use the right hand rule to decide, or you can claim from here, since I cross j is k, then we know I cross j will be equal to minus j cross I, that means because of the negative sign it will become minus k cap. What property we have used over here? We have used that a cross b is equal to minus b cross a. If we change the order, minus comes in, hence this. Similarly, if somebody asks like k cross j, so we will say k cross j is going to be equal to minus I cap. And then if somebody asks to find out I cross k, so I cross k is going to be equal to minus j cap. For all these result, you just try to use right hand rule and make yourself comfortable whether you are getting the right directions. You will be able to get the right directions, and if you are able to get the right direction, that means you can find out the direction of cross product. Now of course these are several informations. How to remember these? For that sake you can use this circle, and remembering is going to be quite simple. So how to remember this, what the answer is going to be of cross product of these quantities? For that sake you remember the circle, and you can write somewhere I and somewhere j, cap, these are caps, and k in a particular order, and in that order you can assign this arrow, and then you can remember like this. If we do cross of I with this order of j, so if we are moving in this order, so the next quantity is our answer. So I cross j will be equal to k, that you can see over here. If we do the cross of j with k, then answer will be I, j cross k is I. If we do the cross of k with I, then the answer will be j, k cross I is j. So this is in cyclic order. However, if we move in the opposite direction, so opposite to the direction will lead to the minus sign. So if we are moving from j and doing cross with I, so you will find we are against this order. So it's not going to be k, rather it's going to be minus k, that you can see over here. Similarly, I cross k will be minus j, I cross k will be minus j, and k cross j will be minus I. Can you see all these 6 results? So all these results can be remembered by this cyclic order of I, j, k. And if you are moving in this cyclic order, so the 2 will be leading the next, the 2 will be leading the next. If you are moving opposite to it, just place a minus sign. Making sense? So this is how we can find out the cross product of directions, or identify the directions of cross product of 2 vectors. Now let's find out how to do the cross product if the 2 vectors are given to us in this component forms. So let's say a vector has been given as a1 I cap plus a2 j cap plus a3 k cap, and b vector has been given as a b1 I cap plus b2 j cap plus b3 k cap. This a1, a2, a3 are components of vector a along x, y and z direction respectively. Similarly, b1, b2, b3 are the component of b vector along x direction, y direction and z direction respectively. And if this format is given to us, so we can find out the cross product. So let's try to write the cross product. A cross B we are looking for. So what we are going to do in a simplest manner, or in a basic manner rather, so we will place the value of A, we will place the value of B, we will place the cross in between, just like we did in case of dot. So A I cap plus A1 I cap plus A2 j cap plus A3 k cap. So this will be representing vector A, and in between we need to place the cross symbol because we are doing the cross product. B1 I cap plus B2 j cap plus B3 k cap. This is going to represent vector B. Now for cross product we will be expanding this expression and writing all the terms there. Now let's expand this. When we are going to expand this, we are going to get 9 terms, right? So let's expand in this manner. A1 I cap will be cross multiplied with all the terms. Now when we do the cross multiply, directions are getting cross multiplied, numbers will be getting multiplied just like that. So first will be A1 B1, and it will have I cap cross I cap. Then this A1 I cap has to be multiplied with this B2 j cap, so it will result in A1 B2 I cap cross j cap. And then this A1 I cap will be multiplied in a cross fashion with B3 k cap, so it will be yielding as A1 B3 I cap cross k cap. This is how first term has been expanded, and similarly we can go further this A2 j cap multiplication, so it will lead to A2 B1 j cap cross I cap. Then this will be A2 B2 j cap cross j cap, and the next term of this is going to be A2 B3 j cap cross k cap. So this is how we got the 6 terms so far by multiplication of these 2 terms. Now similarly A3 k cap has to be expanded and multiply with all these terms to get further 3 terms. So I'm writing over here. So it's going to be A3 B1 K cap cross I cap plus A3 B2 K cap cross J cap, and finally it will be A3 B3 K cap cross K cap. So whenever we need to find the cross product of two vectors or two given vectors, so we will be simply substituting those vectors and expanding it in this manner. Now after this you can solve, because what we need to apply for this value, we have understood what this value is, what this value is. So these cross of unit vectors we have talked about, and we need to substitute their values. Making sense or not? If we substitute their values, then we will find our final answer coming in. Now I, cross product of same vector is a null vector, so this null vector will be nullifying the first term. Similarly, this j cross j will be nullifying, because same vector crossed with itself yields 0 vector. Similarly, this k cap cross k cap will be cancelling out or becoming 0, nullifying. So only 3 terms you will find they will get nullified, and 6 terms are going to remain there. Now if we talk about the first non-zero term, which is a1 b2, so it's going to be written as a1 b2, and this is I cross j. Now as per the rule that we have just talked about, I cross j give us the next direction, which is k cap, so this will become k cap. So that's this term. Similarly, we will be writing further, and it's going to be a1 b3, and this is I cap cross k cap. If you look at the value of I cap cross k cap, is going to be minus j cap. Then we can proceed for the next term, which is j cross I. So j cross I is minus k cap, so it's going to be a2 b1 minus k cap. Similarly, we can further move and write the next non-zero term, which is a2 b3, and it is coming as a j cross k. J cap cross k cap is I cap. You can see from that circle or from the previous calculations. Now next term is a3 b1. With this a3 b1 we are having k cap cross I cap, so k cap cross I cap is j cap, so that becomes j cap. And then final term is k cap cross j cap, so that's going to be minus I cap, so it's going to be plus a3 b2, and this cross product is minus I cap. This is how we are getting these 6 terms. Now if you look carefully in these 6 terms, 2 terms will be of I cap, which is 1, and this another. Two terms will be related to j cap, and 2 terms will be related to k cap. So let's collect this I cap first. So when we collect this I cap together, we will find there's a positive term, which is a2 b3, and then minus, because this is a minus sign, and it's going to be a3 b2. So this is going to be the coefficient of I cap, and then we can write plus j cap. So we can take j cap common, so positive j cap is here, so that's a3 b1, and here is a minus, so it's going to be minus a1 b3. And finally we can collect the k cap. So when we collect this k cap, is going to be equal to a1 b2 minus, from here you will get a2 b1. Though it seems to be complicated a bit, but logically it can be thought of or remembered. So a cross b vector will get this as a formula. Definitely this formula is more complicated as compared to the formula for dot product, because for the dot product we have simply a1 b1 plus a2 b2 plus a3 b3, right? Whereas here we are having a lot more terms. So this is saying A cross B is equal to I cap something I cap plus something J cap plus something K cap. That means you can see on the right hand side it's using unit vectors. That means A cross B is a vector quantity, and that's why it's called vector product. Now just to remember, if you want to remember this, that's A1, A2, A3 are the components corresponding I cap, J cap, K cap, and B1, B2, B3 are components corresponding I cap, J cap, K cap. For B vector, earlier was A vector. So this can be directly remembered as a formula and can be solved. Now what we need to do, we will place I cap, and within I cap is a first, so we will not use the one subscript, we will be using 2 and 3, and we'll be moving like A2 B3 minus A3 B2. So 2 3 3 2 we are going to use and subtract the 2. Then J cap is a second, so 2 subscript is not to be used. 3 1 then 1 3. A3 B1 minus A1 B3. K cap is a third, so 3 subscript has should not be used in this case, so it's going to be 1 2 2 1. A1 B2 minus A2 B1. Right, this is how you can remember it, or you can practice it n times to remember it. So this is how we can find the cross product. So either you remember this, or what you can do, you can simply put there, go for the expansion, make those null zero vectors which are becoming 0, and rest you rewrite, and you can also get out of that. It will depend on the practice. It might appear complicated initially. After doing a couple of questions, it will become very obvious, and you will be able to find out it. So initially you need to do some practice. Apart from this way of doing the cross product, there's another way called determinant method. Using that determinant method, we directly achieve this expression which is written in this box. So let me tell you that determinant method as well. So here is the determinant method of getting cross product of two vectors. Let's say A vector is similar as we have considered earlier. B vector is very similar as we have considered earlier. And we are interested in finding out A cross B. So one way of finding out the cross product is simply going ahead by using the basic method that we just talked about. And another method is this determinant method. For that sake, we are going to say this A cross B is going to be given by this expression. For that sake, we will be making these two parallel lines. These two parallel lines are called determinant in mathematics language. If you have understood, or if you have read this about this determinant expansion, then it's going to be easier for you, or otherwise you are going to study about determinant in 11th and 12th, then after it will become very easy for you. What to do whenever there is a cross product and there are going to be two vectors involved, the first vector and the second vector, and we will make this kind of a two parallel line which will be read as a determinant, and there will be writing I cap, J cap, K cap. So we will write here I cap, then in between J cap, and here K cap. So this is called row, so that's called first row. In first row we are going to write I cap, J cap, K cap, and then similarly there is going to be second row, and there is going to be third row. So these three rows has to be decided. Now in the second row we will be writing the coefficients of first vector which is involved in the cross product, and it's A vector. So this is corresponding coefficient. A1 of I coefficient, A2 is a J coefficient, A3 is a K coefficient, so that will be written there. Similarly, in the third row we will be writing the coefficients or components of second vector, so they are correspondingly B1, B2, B3. Now this whatever this expression is, this mathematical expression, if we can open it, we can get our answer directly. Now let me tell you what is the way to open this kind of determinant. We call this as a row. So first row, second row, third row. We can call this as a column. This is first column, second column, third column. And this kind of determinant is known as 3 by 3. That means 3 rows, 3 columns, total 9 elements. And these individuals are called element. So from here we will be writing whatever the first row's first column point is, that means I cap. So we will be opening along this this row. So I cap directly can be written like this. So how to write this I cap? what we need to do, we need to place a bracket, and in this bracket we are writing the coefficient of I cap. When we are using this element, so the column this belongs to and the row it belongs to, that will be not considered for its coefficient writing. So this column and this row will not be considered. Only this part, that means A2, A3, B2, B3 will be there. Then what we are going to do, we are going to cross multiply these two. So we will be multiplying these two, then we will be multiplying these two and subtracting. So first we need to multiply in this manner, that means A2 and B3, then these two, and then subtract. If we do this, so it will be equal to A2 B3, A2 B3, then place a minus sign, and then multiply the another diagonals, that is A3 B2. If we do this, we will find the coefficient of I directly. Making sense? Then we will be moving towards the next element in that row, which is J cap. Now here the sign goes alternatively, so I cap we will take as a positive, and J cap, before this J cap we place a minus, and then we will be finding out the coefficient of this J cap. When we are writing this J cap or expanding for J cap, so the column it belongs to and the row it belongs to will not be considered. So this row and this column will not be considered. So our element will be A1, B1, A3, B3. Again we will be multiplying in a cross manner. So first we will multiply these two, then these two, and subtract. So by doing this we will find A1, B3 minus A3, B1. A3, B1. So that will be the coefficient of J cap. And finally we can expand it for K cap, the third. So third has to be written as a positive, so it's goes alternate, I positive, J negative, K positive. And then we will be doing the same process. The row it belongs to, the column it belongs to will not be considered. So whatever is left, that has to be considered. Then we will be multiplying these diagonal or diagonally and subtracting. So it's going to be A1, B2 in the first diagonal, and in the second diagonal it's going to be, it's going to be A1, B2 in the first diagonal, good. In the second diagonal it's going to be B1, A2. So it's going to be B1, A2 or A2, B1, whatever you want to write, you can write it. So this becomes K cap. So this is how the determinant is open. You just focus on the process that I explained. Let me quickly re-explain. The first term I cap you are going to write directly, then the column and the row it belongs to will be not considered. Then go for this diagonal, multiply them together, and then this go for this cross product or diagonal product, and then multiply these two, and then overall you need to subtract, place a minus sign. Then do the same thing with the J cap with the minus sign in front of J cap, and then repeat the same thing for K cap with a plus sign. So that becomes opening of determinant. So this gives our answer. If you check, this answer is going to be same as that you calculated by multiplying in terms of 9 terms. Here this is minus sign, you can take this minus sign inside, so these terms will be exchanging, or that means this will become positive, this will become negative, and then all the terms will appear like adding up. But this expression and the previous expression, they are exactly the same. You can check it. Okay, so this is the determinant method. Well, so in this video lecture we have covered very important aspect of vector algebra, which is known as multiplication of two vectors in cross fashion, or we can call it as a cross product or vector product. We defined how this cross product is defined as. We talked about the magnitude of this cross product, direction of this cross product, how to identify these directions, and then we talked about some properties of these cross products. They are all extremely important for us. So make your proper notes, go through it, and then do practice from the assignment or the reference books that I have suggested to you. Well, so that's all for this video. Thank you for watching. Have a great time.